Consider cycle diagram. T1, T2 represent times. So having T1 greater than T2 will have alpha 1 catching up to alpha 2. And so for T1 greater than T2, we have alpha 1, alpha 2, alpha 1, alpha 2. Then we have when T1 equals T2, we'll have the convergence of alpha 1 and alpha 2 onto a specific alpha, and then they will reverse directions, and alpha 2 will begin to move further into the past and alpha 1 into the future. But if we can exchange alpha 1 and alpha 2, in any case, if alpha 1, say, has like a symmetric partner, then we can flip this expression and have them come back into convergence. Oh, but I forgot to note that this would flip the inequality sign. So they would begin to diverge by mathematics, but I think there's some way that they would come into resonance. And so we exchange T2 and T1, and then we get alpha 1 getting pushed further into the past. So I'm saying T1 is a bigger leap forward. So if I had some epsilon, it would jump forward a longer amount, and then T2 was less, so it would end up somewhere in here. And the relationship, if this is recursive, could have me performing this procedure of getting epsilon so close to epsilon that they appear in the same point at the same time, and the resonance collapses onto a single object, epsilon, that exists at a point, and then it goes back into resonance, and we get those epsilon moving away from each other if they don't have inverses, or if they do have inverses, then taking the spin partner and saying, see, but I want my arrows to reverse. Oh, and they do, because I have to draw them over under. And for some reason I'm moving the negative into the loop and reversing the direction that is the future. The future points to the past. And I would expect it to keep moving. Like a mathematician would say, oh, it's just going to diverge forever, but until epsilon is arbitrarily far from where it was in the past. So when T1 equals T2, both T1 and T2 tend towards 0. That's what I hypothesize. So when T1 equals T2, the limit of T for epsilon to epsilon back and forth equals epsilon with an arrow of length of time 0, epsilon with an arrow of length of time 0. Thus giving us epsilon existing in a particular place at any instance when this is true, when T1 equals T2. So I think that would be the path towards highest resonance. That naturally in a situation where we have a time before an event repeats, if that event cycles into the future and then back into the past, then it can converge. But yeah, this is the timeless perspective I want. I need to redraw this. So this would be the general form for this time reversible cycle diagram. Made a mistake here. It's N. This is the extension of this cycle diagram right here to, I'm going to say, a resonance of size N. That is an in-out or an occasional resonance. So what I want is I desire, this suggests a definition for occasional resonance. This suggests the definition that a resonance is occasional when the sum of T 1 from n equals 1 to n equals the sum for n equals 1 to n of t2 of t2 of n. So it goes backwards in time. But depending on how the individual t sub I in a real-world example would behave with each other, I would most likely have situations where for some a sub I they were converging, and for some other ones they were diverging. But if it can hold true to this the entire time, then I would expect the overall series to converge by the same intuition I used for this one, where it kind of almost looks like you could describe it as swirling in on itself by going backwards and forwards in time in this ever tighter pattern until, boing, it collapses the resonance, and then hopefully continues in the other direction and can develop either some periodic motion or convergence on a single point, on just one particular discord, suggesting that that discord is like, might as well be considered resonant. This is a possibility.